All right, we are officially live on YouTube. Welcome, everybody. I wanted to quickly mention for those who are joining on Zoom, if you would like to talk to everybody in the chat, make sure to change that little blue bar to say all panelists and attendees and not just all panelists, because otherwise you'll just be talking to us. And feel free, it seems to be tradition with RASC events to say where you're joining from. So feel free to share where you're joining from and what the weather's doing there. Here it is clear for the first time in ages. So anyone who's in and around Toronto, sorry for taking away your observing. We're gonna have a really great time tonight though. I'm gonna pass the proverbial microphone over to Allendria, who is the editor-in-chief of SkyNews, who will be introducing our event for us today.
Thank you, Jenna. So yeah, welcome to Astronomy Today, Framing the Future, a panel discussion bringing 4 great Canadian minds together to talk about science that is out of this world. As you know, today is February 11th, the International Day of Women and Girls in Science. The day recognizes the critical role women and girls play in science and technology. And so we're here today not to talk exclusively about women being in astronomy, but about the amazing work that women are also doing in astronomy. Women have, as many of you also know, women have worked in astronomy throughout history. From Agnes, the Egyptian princess, to Vera Rubin, the discoverer of dark matter in galaxies, women have made their scientific marks on their societies and around the world. Our panelists tonight come from a range of backgrounds, studying in fields such as observational astronomy, cosmology, astroparticle theory, and planetary geology. They're also astronomy communicators, working on vibrant outreach projects that bring people to the edges of human knowledge. And this panel is presented by the Royal Astronomical Society of Canada and Sky News. As Jenna mentioned, I am Allendria Brunjes, the Sky News editor-in-chief. And so Jenna is Jenna Hinds, RASC outreach coordinator. She's going to be moderating the question and answer portion of tonight. RASC Next Gen committee chair, Emilie Laflèche, and RASC Diversity and Inclusivity Committee Chair, Roland Dechesne, excuse me, Roland, will be moderating the audience discussion. And I wanted to start out tonight with a land acknowledgement, also acknowledging the fact that we're all coming in from basically all over Canada, and we've just got somebody's logging in from Brazil. And so, yeah, we're coming in from all over the world. And we would like to commemorate Indigenous peoples' principal kinship to the land, and that we recognize that they have not been and cannot be erased. Acknowledgements are a starting place to change how the land is seen and talked about. And while we meet today on a virtual platform, coming from communities all over the country and the world, we at RASC and Sky News would like to reaffirm our commitment and responsibility in improving relationships between nations and our understanding of local Indigenous peoples and cultures. And so from coast to coast to coast, we would like to acknowledge the ancestral and traditional and unceded territories of all Inuit, Métis, and First Nations peoples that call these lands home. And now I would like to introduce our panelists for tonight. And so we have, first off here, Sophia Gad-Nasr is a PhD candidate in cosmology and astroparticle theory at the University of California.
Hey,
she engages,
yep. I don't mean to interrupt, but Sophia's actually going to go last.
Yes, I know. I'm reading through.
Oh, okay, all right, okay. Just
I'm reading through the biographies first, and then people can speak. So, so not first tonight to speak, but first in my list of introductions, because my introductions are all in alphabetical order. We have Sophia, and she engages in scientific outreach on a daily basis and runs her own blog, Astroparticle. Particle. She writes about physics in an effort to engage the public in science and help people see that science is fun and interesting. Through science communication, she works to break down the stereotype that physics is hard and raise awareness to the difficulties women and underrepresented minorities deal with in the field. So, hi, Sophia, and welcome to the panel.
Hello, everyone.
We also have Sarah Gallagher, the science advisor to the president of the Canadian Space Agency. Her research focuses on studying growing supermassive black holes at the centers of distant galaxies and the interactions between galaxies in crowded environments. She has over 100 refereed papers that include data from 10 different space observatories, and her research has been recognized with an Ontario Early Career Researcher Award and a Western University Faculty Scholar Award. She regularly speaks to the public of all ages about black holes and other wonders of the universe. And so thank you for joining us tonight, Sarah.
It's a pleasure to be here. Thank you.
And next up is Sarah Mazuri. She discovered her interest in space and astronomy at an early age and has used her expertise gained through completing a PhD in planetary geology to share knowledge about space with the public. An advocate for women and people of color in STEM, her hope is to relay her own passion for discovery into excitement for learning at all ages. And she is currently an educational developer at Ryerson University. And it is wonderful to have you here, Sarah.
Thanks, pleasure to be back.
And a face many of you know through her RASC connections, Nicole Mortillaro is a senior science reporter at CBC. She has an avid interest in all things science. As an amateur astronomer, Nicole can be found looking up at the night sky, appreciating the marvels of our universe. She's the editor of the Journal of the Royal Astronomical Society of Canada, a regular writer with SkyNews, and the author of several books, including the 2021 Night Sky Almanac published with RASC. Hi, Nicole.
Hey, nice to be here.
And so without further ado, I pass the proverbial microphone off to Sarah Gallagher.
Thank you, Allendria. I'm really excited to be here tonight and with this fantastic group of people to share a little bit about my experience with astronomy. And in particular, I'd like to focus on my experience as a space astronomer. So, and I think pretty much every astronomer likes to tell the sort of, the war stories about, going out when the weather was crazy and there were poisonous creatures that were in the way and, all of those great stories. And so as an observer who's gone to ground-based observatories, I certainly have those stories too. The most recent time I went to an observatory, there was actually a scorpion in my bathroom. So that's my dangerous creature story. But but space astronomers have stories that involve I think the utmost terror of putting your beautiful instrument on top of a bomb and launching it into space and hoping that everything works out. And but then once you're able to do that, if you're able to put your beautiful telescope up in space, you're allowed to do things that you can't do from the ground. And so that's one thing that is really, really amazing. And so I'm looking at Sophia's background, and I think that's the bullet cluster behind her. And what is and why I recognize that image immediately is because that is a picture that was taken. Part of it, the purple one, or the pink part of it, was taken by the Chandra X-ray Observatory. So I think that's right, Sophia, right? And so Chandra is the Chandra X-ray Observatory was my first experience with really seeing the inside of a space astronomy mission, because I was a graduate student at Penn State, the Pennsylvania State University. I went there in 1997, and in 1999, Chandra was launched. And I was really lucky because Penn State hosted one of the Chandra science teams because the principal investigator for the main instrument was at Penn State. So that meant that when I was a graduate student, we went to watch the launch, not the actual launch, but we got a direct feed from NASA on NASA TV to go watch the launch. And Chandra was really pretty exciting because it was one of NASA's great observatories. It was launched from the space shuttle, so it went up on the space shuttle. And one of the other awesome things about the Chandra launch, which is particularly relevant for today, is that the commander of that mission, Eileen Collins, was the first woman commander of a space shuttle. So there were lots of things that were special about that launch. Chandra was the largest payload that was ever put inside a space shuttle it's freaking huge. It's the size of a city bus. So it's a really big telescope. It was put in the space shuttle and it was launched into space. And I was sitting at this table. It was a night launch. We had reserved an auditorium at Penn State, and I was with people who had built and calibrated the instrument, the primary instrument, and they were watching their baby, you know, literally on a bomb launched into space. And when you have these big space telescopes, they have they represent decades of people's lives. So the people who start from the beginning, these big projects, they can take decades. And so that was something that was really, for me, it just came home to me as I'm sitting there. I'm a pretty new graduate student. I'm super lucky. I show up at Penn State and this thing is basically pretty much ready to go. And I'm sitting in a room with people who have dedicated years of their lives to making this happen. And then there's just this crazy thing that's going to happen, and they're just hoping that everything works out. And for me, that's a big part of the excitement of being involved in space is doing things that are absolutely crazy because no one has done them before, and you don't, and also incredibly risky. But you know, the payoff is that you can do things like take that extraordinary image and learn amazing things about the universe, as the image that you see behind Sophia. So now in my role at the Canadian Space Agency, I get to see sort of two views of what's going on. I'm a research scientist, so I can really appreciate the value of what we can do from space when we're able to put telescopes up in space. But I also see the other side of it, which is that, I mean, these are giant projects that go on for years, and you have international partnerships, and you have, and you hope that everybody who starts working on a project decides to keep working on the project. And you also, every time you put a space telescope in space, you're doing something that is way, way better than anybody has ever done before. And so it's hard. It's just really hard. And you're trying to do something that nobody's done before so that you can get extraordinary views of the universe. And so it's really challenging and it's really hard. And part of what I feel like my role is as a science advisor is to really help, help exciting new things happen in space for all space scientists. And of course, as an astronomer, that's the one that really resonates with me. So I will, I'll stop there. I don't want to take up any more time. And I know I'm sure we've got fantastic questions, and I also want to hear from all my fellow panelists. So thanks.
Thank you, Sarah. Okay, next up, we have the other Sarah on our panel.
Awesome. I'm just going to go ahead and try to share my screen just so that you can look at some images while I talk. All right, can everybody see my screen? That's a yes. Okay.
Yeah, sorry.
Okay, perfect. Thanks. So I just wanted to share a little bit about my journey and how I ended up where I ended up, just because I thought it's a lot of fun to hear where everyone's coming from and what we're all doing. So my journey started from being really young, looking up at the night sky and seeing something that looked fairly different compared to other things that I would see in the night sky. It was this bright thing with a bright tail. And it was a comet. I guess at that time, I didn't even know what the comet was called. And it took a lot of going back in memory to try and piece it together to figure out which comet it would have been at that age. But what I loved about it was that I would literally walk home. I remember walking home with my mom and looking up at the night sky. And I just wanted to stand there and stare at it for a really, really long time, because I kept hearing that it's like, they're like, this is a once in a lifetime thing. You're never going to see a comet this bright again. It doesn't happen that often. And I was just so obsessed with it because it was so different. And then a few years later, I was lucky enough to be able to see a total solar eclipse. And again, hearing the same thing of this is a once in a lifetime event. Seeing the sky get dark, the birds literally fly home as if it was nighttime and then get all confused and then wake up again. And just trying to figure out it is that's causing this phenomena. Why is this happening? And at that age, I didn't have a telescope, or I didn't really have access to an observatory or a place to see the solar eclipse with these like fancy glasses that we have now. But outreach teams were going around giving out these 2 pieces of cards, basically like the pinhole cameras, with just holes through them so that you could look at these papers to see the solar eclipse and not stare at the sun and go blind. So the whole outreach effort was to prevent people from going blind and staring at the sun, and to use this as a way to look at the solar eclipse. So this is back in Iran, where I was born. And I was just obsessed. I was obsessed with space. And when we moved to Canada, I was in grade 9. And when it was sort of time to pick universities and programs, I walked into the guidance counselor's office, and she's like, all right, well, let's pick like your grade 11, 12 courses. What do you want to do? And I'm like, well, I want to go to astronaut school, because that made complete sense to me, because for any other profession, you would go to school for it if you wanted to become a doctor, become a lawyer. And she laughed, and I didn't understand why, because I was dead serious. But it was funny to her. And then she explained that that's just not a thing. And I was fairly disappointed, because I was so set on studying how to become an astronaut. So then we looked through the list, and she said, well, what about astronomy? You still get to study space and things that are out there. And she explained to me, what the whole becoming an astronaut process looks like. And that's how I ended up taking some courses. And I did a co-op program, actually, by chance, at York University, at the observatory there, when I was in grade 12. And I was hooked. And that's really when I got to interact with people that were studying astronomy, space engineering. That's where I really learned the difference between all of these programs. I didn't really know much about them. And everyone that I worked with at the observatory wanted to convince me to enroll in the astronomy program. And I kept looking around, and I wanted to do something a little different. I was interested in aerospace engineering, but I had just convinced myself that engineering means a lot of programming, and I'm not good at programming. And at that point, I had not even taken a single programming course. I didn't even know what programming was, but I had just convinced myself that it's this beast that I'm not good at and that I could never do. So I'm like, okay, let's look at some different programs. And I discovered a program called Space Science. And you could do it through 3 different streams. You could go through it through the computer science department, through the physics department, or through the Earth and Space department. And I decided to go through Earth and Space because it sounded less scary. There was not a lot of programming. There was not a lot of physics. It was just enough that I could handle, and I could still do what I was interested in. And it turned out to be really interesting. I took a lot of courses in astronomy and engineering, in programming, in physics and math, and I could do it all. I had just mentally convinced myself that I just couldn't, but I actually did. And as I was finishing my undergrad program, I started doing a summer internship with one of the professors there. And at that point, they were working on the very, very, very preliminary concepts of OSIRIS-REx. This was just in the very baby proposal phases. They weren't even sure if they were going to get funded or not. And the instrument that Canadians actually ended up building that is now at Asteroid Bennu was this LiDAR instrument. And my job was to just do a basic research, just to look through all the other missions that had used similar instruments, gather some information, and sort of write reports. So my journey of ending up at planetary science and planetary geology was a little accidental. I was never sure what I was doing, but I was just going in a direction that kept my interests going. And like I said, from the beginning, from when I was in high school, I didn't have a good awareness of what programs are out there or what I could really do. And it was just by talking to people that were around me little by little and learning more. this was a lot of fun because, well, OSIRIS-REx eventually got selected. It got launched. I eventually got to go to Florida and to watch the launch, and it was so exciting to know that maybe I did 2 months of work on this project that's involved many, many people and many years. And it was just really, really exciting. I ended up doing my master's on a different asteroid Itokawa, that looked like an udder. And again, at that point, I wasn't too sure what planetary science is. My supervisors told me to sort of map all the rocks that were on this asteroid. And I did that, and it was very mind-numbing, and I watched a lot of TV at the same time as mapping these. But then they explained to me what the point of all of it was. It was trying to figure out why this asteroid looks the way it does. Why does it look like it has a head and a body? Was it 2 different asteroids that came together, or was it one giant asteroid that got hit and it got this shape? And they told me by studying how many rocks and of what sizes are on either ends, we could try to figure that out. So that was exciting. That was the side of me that loved solving puzzles and mystery and trying to answer those questions. So it was a lot of fun. And at the end of my master's program, I finally got a chance to go to my first conference, the Lunar and Planetary Science Conference. And it was just mind-blowing. There were rooms full of people working on real life missions, a lot of cool science. Everybody was excited to talk about this stuff. And it just fueled my passion more and more. And I ended up working at the European Space Agency for a year between my master's and my PhD. It was the first time that I moved far away from home in a new country. But it was a lot of fun. I got to work on the Venus Express mission. And interestingly enough, I got to study the atmosphere of Venus. And it was only because of the stream of space science that I had picked to do it through the Earth and Space department. I had taken a lot of atmospheric science courses, a lot of radio science courses. So all of those skills that I wasn't even sure where and how I would use sort of just fell into place perfectly. And then I came back and I did my PhD, and this time I knew what planetary science was. I knew exactly what I wanted to do. I wanted to do planetary science. I wanted to do planetary geology. I loved looking at maps, at different data that were done in different wavelengths to try and, again, solve more mysteries. I looked at younger craters on the moon to try and figure out how much the moon was getting bombarded by stuff and how much the Earth was getting bombarded by stuff. And I learned more about planetary geology. So my PhD title is Earth Science. I call myself a planetary geologist, but I never had formal training in geology either. I learned all of that as I was doing planetary science in my PhD. I put myself way, way, way outside my comfort zone. I took a field course to go to Arizona and Utah, and I truly understood planetary geology then. Trying to really go to craters on Earth, to volcanoes, the Grand Canyon, to caves, to things that, to really truly understand features on Earth so that we can compare them to what we see from different space missions. And it was a lot of fun. And through that, I got to do another internship where we mapped out places on the surface of the moon for future astronauts. So if we were to send future astronauts to the moon, where exactly would we want them to land? Because now we have all of that data. We can see down to meter-sized rocks on the surface of the moon. We know the slopes of everything. So to figure out where to land them, where to have them traverse and move, which rocks to pick up because they help answer specific questions. And it seemed like everything finally fell into place. So my love for space, for exploration, for planetary science, it just fit together accidentally, just by sort of following what I was interested in. And throughout that, doing my PhD and going to all these conferences, I always felt like and talking to other women, especially too, it felt a little weird at times. It felt like you sort of had to leave parts of your identity at the door when you walked into a conference, and you just had to be a scientist full on, and you couldn't really talk about any barriers or issues that were around. So with Dr. Tanya Harrison, we started the Women in Space Conference with the goal of having women as keynotes, as panelists, and as having those barriers and issues as main topics for panels so that we could really talk about them, and we could start removing those barriers, and we could really fully be ourselves into places that we come into. And today I work as an educational developer at Ryerson University, and I work a lot with our STEM faculties and our STEM disciplines. And what I do in my job is to try and really use evidence-based teaching and learning methods that really foster student belonging, really using my own experiences, but also literature and best practices in how do we increase the retention of women and minoritized folks in the disciplines of STEM. We hear all these things about we should get more girls into STEM. And I always say, I don't think that's enough. We should really work on removing those systemic barriers and problems that prevent some people from advancing. We know that women and minorities tend to leave the STEM disciplines more than any other competitive field, such as like business or law. We know that because of, I guess, the amount of work that's required in STEM disciplines, there are higher reports of depression and anxiety among students in the STEM disciplines, and even more in women in STEM. So really keeping all of those in mind and trying to create an environment where every student feels like they belong, feels like they can learn, is what I'm working towards right now. And just to end off, something that's been on my mind for the past couple of weeks is that I was talking to someone and I told them I really love what I do now. It sort of combines a lot of my passions, and I feel like I can connect to faculty in the STEM disciplines because that's where my background is. So if I suggest a new teaching method or an experiment, I have a better sense of whether or not it's going to work. And they told me, but a lot of faculty think of people like you in an educational developer role or science communication role as failed scientists. And that was very shocking to me because I don't see myself as a failed scientist. And I'm really glad that tonight we're talking about all these different ways that you come into astronomy and space, and to really appreciate that there's not one straight career path, or that you can still be a scientist but also be an educator, be a science communicator, be in business, be in data science, and all these different fields. And yeah, I think I went on for a long time, so I'm going to stop. But yeah, my main message was that anybody really belongs, and no one path looks like another. So I'll stop here.
Thanks, Sarah. That's great. And I think it's also, I saw the first slide of Nicole's presentation. And so it's a good segue into your presentation.
Yeah, no, thank you. I was thinking the exact same thing. I'm going to look to try and share my screen here. Pardon, I don't have actually PowerPoint proper on my computer. So I'm just going to start this now, I hope. All right. So going off Sarah's presentation. So, I titled mine, How I Turned My Love of Science into a Career, where I'm actually, not a scientist. And riffing off what she said, I often think of how I got here as a science communicator, as a science journalist, as, the old cartoons and Family Circus of Billy, how he gets out of bed and, how he ends up where he ends up. It's not this straight path. And this is something I've actually spoken about to university students and I even talked to my own daughter about, which is, point A isn't always going to take you to point B to C to D. It's a roundabout way. So starting very early on, my love of astronomy was born out of Voyager. The moment I saw the rings of Saturn, the first pictures of Saturn sent back, I was hooked, absolutely hooked. But going the path of Billy, I went to journalism school because I wasn't that great in math. And I knew that I was supposed to be perfect in math if I wanted to become an astronomer. And in fact, I remember when I was a teenager going to the DDO, the David Dunlap Observatory for the first time, right? And of course, seeing Saturn for the first time. That was the first look through a telescope for me in general, and just being floored. And I remember seeing the jobs ads because it was run by the University of Toronto at the time, and being fascinated. Oh my gosh, these so cool astronomers have the coolest job. And I wish I could be an astronomer, but I couldn't be because, like I said, wasn't that great at math. In retrospect, I wish I had listened to my father, who told me to stick with science. But anyway, so I ended up becoming a book editor at Scholastic Canada, which I'm sure many of us know very well from our days of being young and expecting the book fairs and the book club flyers. So the first book I wrote, and then I ended up writing a book, and the first one was Sun and Storms, which is kind of below my elbow here, and then Snow and Ice. And that was because I was also really fascinated with weather. I mean, just Earth systems, big things I loved. And then, but there was nobody there who really liked hockey and knew hockey. So I became a hockey book editor, and then I ended up writing hockey books. So it was great because I was happy, but I really, really wanted to become a science journalist. And that was because back when I was in journalism school at Ryerson, yay, Sarah, we had a TV in our newsroom, and we had Discovery on all the time. And At Discovery was on, at the time it was Jay Ingram, but Ivan Semeniuk, who now writes for the Globe and Mail, he was on there, and I thought that was the coolest thing ever. I wanted to become a science journalist. If I couldn't become a scientist, or an astronomer in particular, I wanted to become a science journalist. But of course, things don't happen always the way you see it, you want them to, and I ended up going into editing. I loved editing. I loved correcting people's grammar, and spelling, and all that stuff. Then I ended up meeting Paul Mortfield, seen here at one of the New Year's festivals. Oh, there's Chris Vaughn right behind. He's commenting, I see, and asking questions. And this is the Kids New Year's Festival in Richmond Hill. And Paul introduced the DDO. I lived around the corner from it. The DDO was closed because U of T had put it up for sale, and I was really upset about this. I had just moved back to the neighborhood, and I met Paul, and he told me about the DDO being run by RASC, and I was like, oh yeah. And he said, you should join RASC. I was like, no, Royal Astronomical Society, no, Canada, that's just fancy talk, right? I can't do that. But I started to volunteer and at outreach events and things like that, and I was having a lot of fun. And then I realized not to be so afraid of it, join the RASC, and I guess the rest is kind of history in that regard. But it was really important to me to also reach out and do my own outreach to people, kids, youth of the neighborhood. I mean, these kids here, this is an apartment building where I was living at the park. There's a kids park right there, and none of those kids knew about the DDO. And it's like, it's right behind you, like literally. So I wanted to teach them astronomy and things like that. And in the meantime, I was at Scholastic. I loved editing, but I was really like, these projects take so long to do. And I was like, I really want to go back into journalism in a particular space in science. So I started my website, which I was saying to Jenna earlier that I let it fall by the wayside today. But I did my website. I wrote some things for the RASC website. I did things for iTelescope, which is also a robotic telescope from around the world. And I was doing astrophotography, and I'll get to that later. But so I was really excited. And I got to become a journalist, a science, environment, and weather. I can't remember what the whole title was called, global. And I got to cover amazing things. See, this was the whole reason why I wanted to become a journalist. And as you can see, there's Sophia right there. This is the launch of Orion, the spacecraft that is going to take us to the moon. That's one part of it. Of course, the other one is run by, is being built by the European Space Agency. And I really fought to go get this covered because I was like, this is so amazing. People are going to love this. It's taking us for a next step to the moon. And I was there. And in this picture, I'm amazed I'm still standing. I'm pretty sure Sophia is holding me up because at that point it was up for 36 hours because of scrubs. So it was great. And I've got to meet some other amazing, wonderful women, including, and I don't know if you can see my cursor when I move it, but in this larger picture, you'll see Jill Tarter, of course, of SETI fame, and of course Carolyn Porco, Cassini of Cassini fame. These amazing women in science, in astronomy. So I was doing what I really love doing, and honestly, I was giddy, and including, I'll tell you, the moment I went to Kenny as a journalist, to see Orion, when I'm at the media center, I literally teared up because I was like, I am here where, all these people were during the Apollo launches and all these amazing missions. And so I felt very giddy. And even meeting these amazing people, I am still giddy. I still get a little starstruck sometimes, including Buzz Aldrin, that was pretty amazing. And that was here in Toronto. So I really consider myself very fortunate that I can't do science, but I can communicate things. And this is really important to me. So now I'm at CBC, and I am a senior science reporter there. I've been so fortunate. I ended up at that job because I left Global because Global got rid of the science beat. Don't even get me started. I was so upset. And then CBC had an opening for a mat leave. And as a single mother, I took a chance and I applied for the job and I got the job. So on a 1-year contract, I was scared out of my wits because I thought, what if this doesn't turn into a regular job? Emilie Chung, who is my colleague, who I was replacing, I couldn't replace her, but covering for during her mat leave, she has a PhD in chemistry. She's amazing. She's brilliant. And I thought, well, she's going to come back. What are they going to want with me for? But it turns out that my excitement and passion for astronomy was something different. And here I am. We are more than 4 years later. I'm still there. So I've been really lucky. One of my favorite things that I have done is I went up to Fort Smith as part of festival, the Tabacha. It's every time I say the name, I mess it up somehow. So it is this amazing festivals, or I shouldn't say festival, but astronomy, festival, the way we have shows here all across, like the Saskatchewan Star Party, etc. And this is the one in Fort Smith. And I was invited to be a speaker with somebody, Roland, which was the first time I met Roland, which was wonderful. And we got to see the Northern Lights. Roland was the first one to notice them, and which sent me into a tiz. And I was so excited and giddy. People are laughing at me because I was totally like a child, because it was amazing. And there I also was, Roland and I were privileged to be on the same stage with Roberta Bondar, Dr. Roberta Bondar, who is honestly an amazing woman. And I'm just going to go off on the side a little bit. It's kind of funny because I interviewed, so when I was at Ryerson, I started a science beat for our paper. One of the first things I did was interviewing actually Ivan Semeniuk, who I've finally been able to meet after all these years, as he is really the person who inspired me to be where I am. But I also interviewed Dr. Roberta Bondar, who was actually at Ryerson working on on something about bone density in space. Of course, we know that she does this. So I met her then. I met her in IKEA. I ran into her on the street down on Yonge Street one time, and I kept bumping into her. And when we bumped into each other at the airport on the way there, and she looked at me and said, "I don't know if you remember me, but," and she said, yeah, "I'm going to start to put a restraining order on you soon." And it was because we just kept bumping into each other. And of course, I've been so privileged to, see her again at work at CBC, and of course, Chris Hadfield, Commander Hadfield, who's been amazing. And I've been so privileged to be on the same screen as he is. But one of the things that I really take that is really important in my job as a science communicator, and I know that everybody here feels the same thing, is trying to put things into perspective. Now, the Daily Mail is just the worst example, or maybe the best example of science gone wrong. You can see here 3 huge asteroids up to 100 feet will skim past Earth this weekend, NASA warns. And so, there's this tendency of science communication gone wrong because there are people who aren't necessarily, either that's clickbaity, which this seems to be, or they just don't understand it. So you have an example like this, but how I cover it is more like, hey, 3 asteroids will fly past Earth on Saturday. Here's why there's no need to panic. And it's really important to me to actually communicate that with people so they really understand it. That being said, I just noticed that the Daily Mail has a similar story today on how this 2001 FO whatever asteroid is passing by. It's the size of Burj, the building. And they're saying, it's passing by. It'll be 5 times more distant than the moon. I'm like, and that's the thing. Do you understand how far away the moon is? But and then again, here's another one: water found on Mars. Scientists discover there could be alien life on the red planet. And is a more subdued thing and how I cover it. And that's really important to me. It's just about trying to put things in perspective and communicate science to people, but also to let them in on things that maybe they just didn't know about before. And that's some of the things that I really enjoy doing as part of my job. I also, of course, have a telescope. I went to Starfest, a star party. That was the word I was looking for, star party. And I take up my telescope and I do astrophotography when everything works. Wink, wink, Blake, who's out there. Who actually, this photo, he helped me try and fix my gear. But and it's a lot of fun. The thing is, though, there aren't a lot of women who do it, or at least I think there's an issue when it comes to women to us, where we're a little bit more reluctant to show our work. And so one day, actually, this was in part spurred on by another RASC member, Katrina, who had mentioned something about, the journal, why don't we have more astrophotos from women? So it was like, I don't even know what time it was, midnight, 11 o'clock at night. I was working on the journal, and I sent this tweet out at 10:49 p.m. And I, said, I want to see all the female astrophotographers out there. Just put that out there. Went to bed, woke up in the morning, checked my Twitter, and I'm just scroll. And then there's that little thing that says load more. And I was like, what? And this isn't even the most views or likes or retweets that I got. This was just in the middle of it. It blew up until something, which I'll show you the other tweet. Recently, it was the most active tweet I'd had. And it was amazing to see these photos from all these women. It blew my mind. I finally was like, oh, okay, well, here are some of mine. And, try to be a little modest, my Orion Nebula is a little out of focus, but hey, that was with my own telescope gear and then using my solar scope, who now lives with someone who's taking great care of it, as I had to get rid of it. And so it was so inspiring to see that many women who were interested in this. And so that's part of my job as well. That's why I like doing SciComm. But now I want to take a second to acknowledge what month it is. and that's Black History Month, which is very important to me, not just because of my own, you know, I'm half Guyanese. My mother is Guyanese and my father is Italian. I tended to really identify with my Italian side, not so much on my Black side, because I lived with my dad for most of my life. And I felt like I missed out on a lot on that experience. But, you know, this is my identity. I am, you know, of two minds in a sense, right? When you identify with your race, that tends to happen. So one day I saw Phil Plait tweet out at that Astro chick talking about, you know, the hashtag Black and Astro. And I was like, oh, okay, I'm gonna do that again. I'm gonna, yep, I'm Black and Astro. That showed up again, not really thinking about it. And that tweet blew up. As you see, there's 2,000 likes. That one just went wild. And actually, it wasn't, surprisingly, it wasn't just the Black community. It was so many Black women. And that is something that I have been really inspired with. And now, and this actually happened after the incident that happened in Central Park, where a Black gentleman was birding, and this woman accused him of, called the cops on him and lied and said that he was attacking her. So, you know, there was a movement started, you know, there are Black people in astronomy or in physics or in chemistry in birding, and Black in birding was the first hashtag, and it went on and it was, it caught on in this Black in Astro. But we also want to look back. There have been people Black in Astro way before. And of course, it started off with Katherine Johnson, who we all know, of course, thanks to the book and the movie Hidden Figures. And honestly, I didn't know better until the book came out. I was just like, what? How did I not know this? And this was something that I think was a big failing, you know, across the board. And we don't get Black people, Black women are not acknowledged as contributing to astronomy or to astrophysics or anything, engineering, etc. But there's me, Jameson, who, of course, the first Black female astronaut, who's awesome. And come on, she was in Star Trek. So that was pretty amazing. I was really inspired. And of course, I'm just going to throw that out, you know, who really, she was a Black, it's a fictional show, but I've heard Black women talk about how she was an inspiration. But there's not just Black women of, you know, yesteryear, there are Black women of today. And these women are looking to be heard. It is difficult. I've spoken at length. I am working right now on a Quirks and Quark special on being Black in science and looking at systemic racism, scientific racism, but also the current climate, why we're here. And a lot of times you talk about, it's hard for not just women in science, but also women of color in science as well. And this was Ashley Walker, who was at that Astro chick, who started Black in Astro and the hashtag Black in X. So I'm so grateful for all the work that I do as well. You don't see very many women science writers, psychom women. It's improving, you know, but I think I'm so fortunate to be among them. And I, you know, thank you to all these women here who are doing amazing work. I'm in awe of everything you do. And I'm privileged that I can share your work and your knowledge with everybody. Peace out.
Thank you, Nicole. That's great. And so our last presentation tonight, well, not last, we've got the Q&A as well. We have Sophia Gad-Nasr. So take it away. Thank you. Just need to unmute.
Hi, sorry about that. Yeah, I'm just trying to get my screen to cooperate. I should have this ready in 1 second. Okay. All right. Alrighty, here we go. Can everyone see my screen?
Perfect.
Mm-hmm.
Great. Thanks for having me. I'm really excited to give this talk. My talk's a little bit different. It's really mostly based on just the work that I do. And I hope that doesn't bore you. So,
no, definitely looking forward to it.
great. So physics is the art of asking questions and wanting to understand how things work, be it the trajectory of a ball when you throw it, or why stars tend to group to form galaxies. It's how we progress, how we went from horse and carriage to electric cars. It's the art of uncovering mysteries to better understand the universe that we live in. And this is in a nutshell what I try to do, uncover the universe's mysteries. And there are so many of them. One of the mysteries that in the universe that really interests me is how supermassive black holes form. Like everyone's favorite gargantua from Interstellar. So black holes are objects that form when you cram way too much matter into a really small space. So the effect of gravity at that point will cause it to fall into an endless collapse that tears the very fabric of space-time and forms this really super dense object in the center, which is a black hole. And gravity is so strong in these things that not even light can escape, which means that we also can't see them. So we understand the formation of stellar mass black holes very well. So a very massive star ends its life in a explosion, in a supernova explosion. And there's so much mass in such a small space that gravity takes over and pulls back much of the expunged mass so that it kind of pulls it back in, and then this all collapses into a black hole. But stellar mass black holes are like, at best, 100 times the mass of the sun, and that's going way too far. Like they're not even that massive right now. And so that doesn't explain how we get these giant colossal black holes in the centers of galaxies, including our own. So how does that happen? Like take the first image of a black hole that we got from the EHT collaboration. It's 6 billion times the mass of the sun. 6 billion times the mass of the sun. How can this be? How did it have enough time to form? Like, could it be that stellar mass black holes just merged and, ate or accreted matter over the age of the universe? Well, that's not going to solve the problem, because we actually see these things at like 700 million years after the Big Bang. So the universe only had 700 million years and less than that to form these, or to or the black holes would have had not enough time to accrete or merge into these supermassive black holes. So in fact, if I take this calculation, or if I assume that that black holes accrete perfectly, consistently, at these really high rates, it's something that we call super Eddington accretion. If I do a quick calculation using an initial mass of a black hole being 100 times the mass of the sun, it tells me that in 700 million years, I'll get a black hole that is 100 million times the mass of the sun, which is a factor of 10 too low for the black holes that we see when we're seeing black holes that are 1 billion times the mass of the sun at like 700 million years after the Big Bang. And so, and again, with this accretion, we are, if you take it into practice, nothing's going to accrete perfectly and consistently all the time. And so even that is like a really high end estimate for that. So we know that's not how it works. And we're left with this mystery that is unsolved. How are these supermassive black holes formed? Another mystery that excites me a lot, that a lot of you might know me for actually, is what the universe is made of. So the things that you can see and touch, like stars, your laptop, your hamster, things that you know and love and are really accustomed to. those are actually a really small fraction of what the universe is composed of, and the rest of it is made up of stuff that we don't understand. So a huge 70% chunk of this stuff, or 68%, goes in the universe, is owed to this stuff that we call dark energy. And what it's doing is it's stretching the universe apart faster and faster with the progression of time. We can see, and we know it's there because we can see these effects that the expansion of the universe is accelerating, but we still don't know the nature, and we're far from knowing what the nature of dark energy is. And then the remaining 30% is matter, which actually sounds comforting at first, until you realize that only 5% is the stuff that we understand, and 25% is also made up of matter that we don't understand yet, and we call it dark matter. So 25% of the universe is content, and it's similar to regular matter in that they're both subatomic particles. Like dark matter would be made up of subatomic particles. Normal matter, regular matter, is also made up of subatomic particles at the heart of it, including us and your hamster and your laptop and everything that you see. But they differ drastically in the way that they interact, and this changes everything. So dark matter doesn't interact with light at all, which is why we can't see it. And it doesn't interact with us or the type of matter that we're made up of either, which means that we can't feel or touch it. And this stuff is everywhere, literally everywhere. So that means that it's passing through you all the time, even right now, and you can't even feel it. Which is incredibly mind-blowing, but that's actually also part of the reason why we haven't detected it yet, because it doesn't interact with the stuff that we understand. And it might seem like we've reached a dead end, but luckily, dark matter and regular matter actually have something in common, and that's that they both interact with gravity. And because we have a really good understanding of gravity, we have a cosmic-sized, solar system-sized sort of lab, which is our solar system, to test gravity in. And so we think we understand it pretty well. So the way that we can test it, because both regular matter and dark matter interact with gravity, is that we can track the stars and see if they're behaving the way that they're supposed to, if this galaxy is made up only of the stars and gas, throw in gas too. But we find that that's actually not the case. So the moment that we look up and observe these galaxies, we find that stars are moving way too fast. So these galaxies don't have enough mass for the stars to be moving as fast as they are, if it's just regular matter we're talking about. And also, because they're moving so fast, these galaxies would fly apart because they don't have enough gravitational potential, which comes from mass, to hold them together. And so we can tell that it exists because of the fact that it interacts with gravity as well, but we have no idea what it is yet. So we have these two really cool mysteries that leave us with these two questions. What is dark matter, and how are supermassive black holes formed? But what do these two questions have in common, you're probably wondering? So it turns out that the answer to this question is highly dependent upon what kind of interactions dark matter experiences. So we know, as far as we know, dark matter is only interacting with gravity. But what if there's like a whole dark sector of dark matter, which includes dark forces, so that dark matter experiences these dark force interactions with some forces we haven't discovered yet? And of course, I had to throw in my iconic Darth Vader gif right here, because we're turning to the dark side. And so one type of dark matter that has these dark interactions is called self-interacting dark matter, and that's the type of dark matter that I work on. So the way that this works is that these interactions that it has, the scatterings that it has, effectively redistributes the dark matter in the galaxies that they're sitting in a way that at first can kick out matter from the center of a galaxy, which makes the central region less dense. But eventually, this actually kind of turns around, and the central region starts to contract and become increasingly dense. And so I'm really proud of this work right here. It's something myself and my friend Catherine Machin, which some of you know, are working on together. So she's doing the art, and I'm telling her the sort of the physics that's involved. And so we're taking that and sort of trying to make a physical representation of it. And this is how far we've gotten. It's not complete yet. So, but I'm still very proud of it. And so, okay, so let's talk about how this thing works. So it works by the scatterings that dark matter particles have will exchange heat and energy. And so the collisions will begin in the central region, because the central region is going to be the most dense of the entire galaxy. So that means that the particles are closer together, and that they have higher chances of scattering off of each other. And these scatterings transfer heat and mass outside of the center at the beginning. And eventually that leads to the center losing kinetic energy. And because it loses kinetic energy, then the dark matter will eventually start to contract, so that you're having a contracted central region where mass is accumulating. And what did we say happens to space-time when we cram in too much mass into one single spot? It leads to the formation of a black hole. And if this dark matter halos in the early universe can do that, then we'd end up with black holes that are quite massive. In fact, like maybe about 10,000 times the mass of the sun, which places us in a much better situation than we were in before. Where here, if I redo this calculation and I throw in my initial black hole mass as 10,000 times the mass of the sun, and I take it, for when the universe is 700 million years old, I get a black hole that's about 10 billion times the mass of the sun, which is, which totally can explain all the observations that we are so confused about and that we see. And so, and because even if we were to turn down this super Eddington accretion so that it's not as efficient as it's, as ideally it would be, because that's not how things work in practice, it's okay, because we'll still end up with something that's over 1 billion times the mass of the sun, and plus we'll have mergers and stuff like that can make up for it. So that's what these two things have in common, is that if dark matter halos, or rather if dark matter particles do interact, then dark matter halos can collapse into intermediate mass-sized black holes. And so with this, I get to solve two mysteries: the nature of dark matter, the particle nature of dark matter, and how supermassive black holes are formed. And so with that, I'm going to leave you with a quote from the astronomer Vera Rubin, which we've already heard about, who definitively discovered dark matter in our neighboring galaxy Andromeda. And she says, "Don't shoot for the stars. We already know what's there. Shoot for the space in between, because that's where the real mystery lies." And that's what I'm trying to do. Thank you. And the reason, I just have to mention this, the reason why I put this picture up as well, because I love hamsters and they're my hamsters, but this little girl here is named Gravitini, which is named after the hypothetical particle called the graviton, which would mediate the gravitational force if it was a force.
Oh, I love it. So cute.
Great quote and great hamsters.
Yeah, I love them too.
Gee, Sophia, I didn't know you liked hamsters so much.
Oh yes, I do. I love them. I always name them after particles or subatomic particles, and so I somehow tend to weave them into my talks all the time.
That's great.
Awesome. Well, I think that we can get started with the Q&A. We're coming on 8:05 Eastern Standard Time. And so, Jenna, this is you have the Q&A. So
alrighty, I wanted to just quickly mention Sophia and Sarah as well, a mutual friend / professor of ours, has been messaging me at the same time and mentioned that, Sophia, you have or you at least had at one point a hamster named Neutrini as well.
I did. Yes, I did. I had a hamster named Neutrini.
Amazing. That person is Ben LaRouche, and he's a professor.
Ben.
Yeah.
Yes, he was my TA in undergrad. Oh my goodness. Yeah, and then we kept in contact. It's great. That's so cool. He's here? Hi, Ben.
We were texting in our group chat.
Oh, I see. Okay. Well, tell him I said hi.
I will. His satellite just took a photo of his workplace, like the satellite that he built. Just took a photo.
That's awesome.
And he sent that, and I was like, well, the timing is great.
Yeah, that's awesome.
Super cool. I had no idea that, anyway, the space world is small. So we're going to get into a Q&A. I'm going to start with and a bit of more of a discussion. I'm going to start with some lighter questions, but we have some really, really, really big questions that I really want to get to. Of course, I do want to start things off with some of our youth members. We actually have a youth member who I believe is still in the chat, Tara, who has a question for the panel. Oh, but I didn't share my computer audio, did I? Hold on. There you go.
And I am from Montreal. Hi, my name is Tara. I am 13 years old and I am from Montreal. I first started astronomy when I was 8 years old, and I was wondering, when you first started astronomy, when you knew that you wanted to become an astronomer, and the useful skills that you learned along the way.
So thank you, Tara, so much for that question. Would anyone like to kick us off? Nicole, you or Sarah? Sarah, go for it.
Sure. So my story is maybe a little boring compared to some of you who are struck with the astro bug as children. I actually got the astro bug later when I was an undergraduate. I thought I was going to be an engineer. I feel like a lot of our stories here are about the stuff we thought we were going to do that we didn't do. So I thought I was going to be an engineer, and I thought I really wanted to be a chemical engineer. And then I took a chemistry class and I realized that was not my thing. But I really, really, really loved my physics class. And part of it was because we started immediately with talking about relativity and just that idea that the intuition we have about the world in certain cases is really not correct. So there's the way the world is not the way we might guess based on our sort of experience of normal things like hamsters and throwing balls and all of that. And as part of, so I decided to do physics. And I will say also in my first physics class, one of my early physics classes, I was basically one of the only women, and then the other one didn't take the second semester. And so I looked around, I was like, well, darn, I can't quit now. So gotta stick with it. And then I took an astronomy course as part of that, because that was one of the possible electives. And what I loved about astronomy was that the big questions were in your face immediately as soon as you start studying it. I mean, we don't know what most of the universe is made out of. We don't, how do we get those giant black holes in the centers of galaxies? Like, there are all these amazing questions. How unique is our solar system? Why is our moon so big? Like, there's all these amazing questions and they're just in your face right away. Whereas with a lot of physics, especially if you study it as an undergrad, like, you're studying physics that people figured out 150 years ago. And you need to learn that stuff, but it's not really exciting. Whereas what is 87% of the universe made of? Like, that's really exciting. And so that was sort of how I got hooked. And I took a little bit break before I went back to school, and I actually taught high school. And I would say the things that I've learned along the way, some of the most important things were that, being really curious is probably one of the most important things that you can be as a scientist. And every scientist I know is really curious. They want to know why, and they want to understand how things fit together. And I think that's probably one of the most important skills. And I would say one of the other things that I've learned that's really important is that you need to have your team, and your team might be people who you work with, but they can also just be your colleagues. They can be the ones who cheer you on when you've had a really bad day. When the first thing you do when you start graduate school is fail a big exam, that was me. You know, those people who've got your back when things are tough, when you're not sure if that's what you want to do, when you're nervous about talking to somebody because you made a mistake. I mean, all of those different times when you have to do something really hard and you're not sure if you can do it, having people who've got your back, whether they're your friends or your colleagues or your family, is really, really important. And so that's something that I think really it makes the journey fun too. I mean, I love trying to figure out things with people who I can bounce ideas off and who are really smart and who give me the benefit of the doubt. And that's a reason I really, you know, keep doing what I'm doing, is I really enjoy the people I work with as well. So that's my answer to Tara's question. Thanks.
I do think having those people around you to support you it's just so important. And I'm sure I'm going to throw this over to Nicole, because you've had quite a strong community to help you in astronomy as well, right?
Absolutely. I'm very fortunate to actually even have the RASC. You know, this was such an important thing that really fueled my interest. When I was younger, however, I will say not everybody, including my family, really supported or really was driven as much as I was for my love of astronomy. But there's, you know, I mean, as I mentioned earlier, my love of astronomy came when I was 8 years old. And, you know, it was, a lot of it was, I did on my own when I was very young. And it was, you know, when you're a teenager, you kind of, at least I did, you know, shy away from these, you know, your likes because they seem not cool, which changed for me in 1989 during the solar max when I saw the Northern Lights and just freaked out. And so then, like I said, in my roundabout way, I ended up having idols, I want to say, and like, or mentors. They didn't know they were my mentors, but also Terence Dickinson, for example. You know, he was a huge, every Sunday in the Toronto Star, read his column. I got all his books. Actually, my laptop is sitting on the Backyard Astronomer's Guide, old version. But also, like I said, Ivan Semeniuk. And then when I came to the RASC, it was an incredible thing. And like I say, my big shout out to Paul Mortfield, who really made a big difference in my life. And that is why I had the confidence to go into science communication. And one of the biggest things that I've learned, you know, I'm not a scientist, but I am a science communicator, which is the importance of communicating science. And that means making it easy to understand. And in the time that I have been a science reporter, I've heard time and time again from scientists and from people in comms who say, like at universities and academia, they say, we are trying to teach the importance of communication to our science students and to, you know, so they can also learn how to communicate such amazing ideas. You know, I was really enthralled with Sophia's talk, her presentation, because I'm like, in my head, I'm like, okay, I got this. And that's what I really have to do as a science communicator, is go, okay, wait a minute, explain this to me again. Or, and that's been really important to also have people like Sophia and Sarah, who I do speak with, and I know I've been fortunate to know. So I consider myself, again, very lucky, but they're very important things.
Sophia or Sarah, would you like to contribute to that question, or would you like me to dive into the topic of science communication?
I can add a couple of things, echoing on what Sarah said. I think the first thing would be to continue asking a lot of good questions. I think that's what all scientists are about, asking good questions and trying to figure out ways to answer them. Another thing for me is to really put myself outside of my comfort zone. There are a lot of times where I don't think I can do something, or I don't want to do it, and I end up pushing myself to do it, and they turn out to be some of the best things that I've done. So to really challenge yourself. And I remember, like in high school, anyone that I talked to and I said, you know, I loved math and I wanted to do astronomy in space, and they'd be like, really, like ew, math, or like, why don't you do something else, nursing or whatever. I mean, that's fine. But not everybody has to follow the same path, and you can sort of figure out your own path. It's okay to change your mind along the way and to do something different. And to keep in mind that everybody faces challenges. There are ones that are within our control, and there are ones that are outside of our control. And again, having that support network, but also to just keep pushing forward in your own path, in your own way that makes sense to you.
I'll say a little bit as well. So again, I'm going to echo what everybody has said. Sarah just said it. Sarah also said it. Sarah and Nicole, that the support network is so important. That can get you through like the worst times. Having someone to talk to who can understand where you're coming from, and it's really helpful. And just, yes, don't be afraid to ask questions. There's no question that you have that somebody else is not thinking at the same time. And this is something that I think people don't realize often. And so when you think of something, you're like, I don't know if I can ask this in class, it's going to look really stupid. I should really know this. You're not the only one. You're not the only one thinking that. And so being that person who comes out and says, hey, I have a question, you're actually helping a lot of people, including yourself.
Thank you so much. You're absolutely right. It really, being able to ask questions and being confident enough to ask questions is so important. We've all of you have touched at various points how circuitous your journey through space has been. And we had a couple people asking questions, very specific questions about like how to get into space from a certain field. And that mostly was related to biology. And I was wondering if anyone would like to comment on how you can get into astronomy from different angles, and perhaps maybe the availability of these ideas and how to inform the next generation of the options available to them. Anyone other than me with a biology degree also.
I can take that. I actually work with interdisciplinary teams a lot. And I think it's true, not just in astronomy, but in lots of areas where you need expertise from different areas. And you need people who have an expertise that can come together and figure out how to talk to each other. So there's the science communication to the public, but there's also science communication to other experts in different fields, and that's a real skill that's important. So, for example, there's the field of astrobiology, which has lots of different applications. There's the application of in our solar system. Are there other places in the solar system where life could be supported? And then also, if we look at other solar systems outside of ours, are there environments in which we can imagine life? And also, how did life arise on our planet? And those are all questions that you really need biologists to answer those questions. And so part of what somebody who's interested in getting into the astrobiology field can do is go hang out with astronomers, find places where those people are in the same place. And you have expertise that they don't have. And part of it also is just learning each other's language so you can actually communicate. But there's a lot of spaces in astronomy for people who, astrochemistry is a field, and there's tons of fields where you really need experts. Atmospheric sciences, that's really important for looking at other planets in our solar system. So there's all these different areas in which expertise from other fields is absolutely essential and really valuable.
I just wanted to say, I think that you bring up chemistry and astrobiology. I remember watching Star Trek where those were words and careers that sounded ridiculous and far out, and yet here we are where these fields are real. I think back then it was xenobiologist is what they would call them on Star Trek or sci-fi shows, and here we have these jobs, these amazing jobs that are out there for anyone. And I think that people, you'd be surprised at what can open up for you along the way. Don't give up. If you love astronomy, if you love whatever it is you love, study it. I'm self-taught. really. I'm self-taught because I've been doing it for 40 years. It's just, don't give up, because you never know. What seems like science fiction, for example, today could actually be something where, where somebody can actually have a career.
On that note, does anyone else have, like, were they inspired by astronomy TV shows or space TV shows? Because Firefly definitely did it for me. I don't know about you guys.
The Martian, period.
Oh, that was a good
I
one.
remember watching The Martian when I was actually late. It was in CJEP, which is like pre-university, for those who don't know what CJEP is. And it was like a huge inspiration for me. I'm also pursuing astrobiology, so if anyone has any astrobiology specific questions, let me know and I'll try my best to answer them. But yeah, that movie was great.
That's amazing that you're in astrobiology, gotta say. Wow.
That is super cool. My brother is a wastewater engineer, nothing to do with biology, but every time that when we come to talking about space careers, he's like, you know what? Eventually there's going to be a career for every single job on Earth except in space. Someday I'll be a space plumber. And it's like, that's the dream.
I mean, that's the thing, right? Like, everybody comes into, let's say, a field like astrobiology, which the panelists have done a great job at explaining how interdisciplinary it is. They each come into it with a very different skill set. And we need that. Like, we need more people who are interested in things that, typically speaking, we wouldn't necessarily think that astrobiology would entail. Just because it has the words astro and biology in the title doesn't mean we also don't need chemists and engineers and just all different types of fields. We really need them, and your expertise is valid. And I think that's something that's important to share also with young women who are maybe a little bit confused as to what they want to do in the future. Like, don't worry, you can do literally anything you want as long as you have drive and motivation to keep going.
I see Eric Briggs mentioned The Expanse, which is a fantastic show. And I was thinking about that as well. The Expanse is, I mean, especially because it's more rooted in science than probably any other show, sci-fi show out there. But yeah, you look at that and they do have plumbers, in The Expanse, people who are out there.
Oh yeah.
And also, I look at Star Trek Discovery now, where the protagonist is a woman, and I really hope that, like, I there was one scene where I was like, there is not a single male in that thing. That is awesome. Like, no offense, guys, but it's nice to see. But yeah, like, it's hopefully the science fiction shows of today are definitely inspiring the future generations.
You hear that, Sarah Mazuri? You get into sci-fi now.
Oh, Sarah.
Because your life is basically sci-fi. You do research that essentially is a sci-fi, so it's all good. We forgive you for that.
Yeah, that's fair. On that note, and Sarah, you brought this up when you were talking about how someone, I just about lost it. It's a good thing my microphone was muted. About someone saying that science communicators are failed scientists. That made me so sad. And someone asked in the comments as well, why do we allow, accept, and embrace such a narrow definition of the word scientist? And I thought this might be a good thing to talk about, especially when it comes to us at RASC. We're an organization of amateurs, and scientist can be quite exclusionary. I just can't imagine not feeling like, it feels so important to identify as a scientist,
Yeah, I mean, it's not the first time that I've heard that, or I've sort of heard that conversation. But I feel like when we think about academia in general, historically it's been such an elitist thing to be able to go to university and get a degree. And then where do we draw the line? Is it if you have a bachelor's, if you have a master's, if you have a PhD? Jenna and I worked at the Ontario Science Centre. And when you wear the white lab coats walking around there, any kid that walks in and says, hey, you're a scientist, you're supposed to turn back around and say, you're a scientist too, because you ask a lot of good questions. And truly, that's what all scientists are. They just ask a lot of good questions. And then what happens next? So you go to university, you get a degree in science, and you decide that you don't want to be in academia or in the lab, for example, but you still love, I still talk to journalists, for example, about upcoming space missions, because I can still, I can still read about those missions, I can still understand the details, and I can translate it into something that's more understandable for a broader audience. I can still work with academics and talk about education, talking about how to make classrooms more inclusive so that everybody feels like they belong, and to talk about those different aspects. But at the end, I'm still using my skills as a scientist, putting that scientific method, coming up with an idea, with a hypothesis, testing it out, that whole process of being able to still do research, whether it's about, reading about, I'm talking about Mars missions in the past few days, and Mars is not my forte, but I can read it and I can understand it and I can talk about it. So still applying those skills, and like the mentions in the chat and in the questions as well, that half of the RASC community, if not all, could be scientists as well. Amateur astronomers or real astronomers, really. It's, to me, it's a lot about title, and I think a lot of us who do have the doctor title or whatever are extremely privileged to be able to go through that system, to navigate that system, to have the privilege to go through it and have those titles. So to me, it's really, it's silly. Like when they told me I'm a failed scientist, I'm like, well, I have a science paper that's as scientisty as science gets, so I don't really care, but whatever.
Mm-hmm.
I can't believe someone said that to you. I just have to.
Well, they didn't say it to me. They said people think of people like you as failed scientists. And I'm like,
still, I don't know.
It's pretty shocking. I don't know how I would respond to something like that. So
yeah.
I mean, this is actually, it seems like a prevailing view for anybody who's in science and leaves the field, period. Like you go and work in the industry where you need that degree and you're a failed scientist. It's a part of this sort of weird stigma that we still have to get rid of, because as has been said, like science is really the art of asking questions. Like if you ask questions and you get curious about something and you want to know how it works, or a little bit more about, what it's made of and stuff like that, you're already doing science, And so I think becoming a bit less, I guess, hard in terms of what you define a scientist as is also a way to move forward in the future to make it more, I guess, a friendlier place.
And on that note, we had someone asking, how do you get kids and girls interested in science? How would you all, what do you think is the most important thing to either include or leave out to get young people and young girls interested in science?
Can I say something? All you have to do is stop with the what's it called? Like the stereotypical, okay, you're a girl, so you got to be a ballet dancer or something like that. If you stop with that and let your kids decide, trust me, they're going to get excited about this. That's all you need, because women are also people. And so when we're little girls, if we're not clouded with the stereotypes that are kind of pushed on us from the point that we're born, then all you have is an open mind, and it's kind of taking in whatever you give it. So just, that's essentially, I think, where it ends. It's not that, or rather where it's at. It's not that girls aren't interested in science. It's that we are placed in this box by society that tells us that we shouldn't be doing science and that we're not good at science. And so when you walk into a classroom with that mentality, it doesn't matter. Like a lot of times you'll just be like, it's not for me anyway. I'm not supposed to do this, so why should I care?
Can I just say, if anybody has a good way, please let me know. I have an 18-year-old daughter who does not like it. So, and she says it's my fault because I foisted it on her, but she volunteered at the DDO, actually, when she was quite young. But also, I think it is that, and I just saw a comment come up saying, math is hard, kind of thing, that idea. I was told when I was in grade 2, and I remember this to this day, that I was stupid and that I would never get math. And I think that was part of the reason why I was so like math phobic. But that being said, I think it's also important to let kids know that it's never too late to learn. I personally have at the back of one of my books, like formulas written out where I'm learning about different formulas and things like that. But and sometimes they just don't like it. But long as you give it, like Sophia's saying, say that's out there for you. If you want it, it's there for you. That is the most important thing. And but also I think personally there's a hands-on stuff too, because even my daughter, she may not like astronomy, for example. We did terrible things like, she told me one day that if you take a chip bag and put it in the microwave, it like compress. I'm like, let's see what happens. And we did it, and we tried that. I told her one time that, if you take a foil and put it in the microwave, this is what's going to happen. She got so excited. So I think that hands-on stuff is really important to show boys or girls and let them just keep it open for them.
Can I actually add something? There was somebody, Susanna Harris on Twitter once, she just recently said this, and I think that this is something like super important. Like if we can give kids a telescope and a microscope from childhood, that's it. That's all they need. And it gives them the toys to do the hands-on activities that you were suggesting too, Nicole.
And Sarah, you wanted to add?
Yeah, so I think there's a couple things that you can do. So one is just, seeing kids, and I think this is related to what Nicole said, and just your expectation should be that they can do it, not that they can't. And you have to tell them sometimes, because especially kids who maybe don't see themselves as, in this kind of role. So you need to say, I think you can do this. And also that it might be hard, but it's hard for everybody. And so that just means you have to like stick with it, not that you can't do it, that there's something about you that's missing that means you can't learn math. And also if you don't like math, at some level, there's lots of other ways to be a scientist too. So I think being open-minded about what scientific practice is. I know a lot of philosophers of science. So, they don't like hands-on stuff. They don't like the lab. It's all in their head, and they have these beautiful abstract minds, and that's how they like to think about science. So there's lots of different ways, from the very abstract to the very concrete to the very verbal to the very analytic of engaging with the world and trying to figure it out. And they're all necessary in order to have a complete picture of how things work.
Yeah, and if I've been thinking a lot since yesterday, actually, I saw a post and I realized that it's so true. This whole concept of getting girls interested in science and STEM is such a Western world thing. It's such a North American thing. It's not a thing in many other countries. Girls are very interested. There's no notion of we need to get more girls into STEM. And I think it really comes down to the society norms. You walk into toy stores and there's like the pink aisle and the blue aisle. That's where the root of the problems are, because all kids are born curious. They all ask a lot of good questions. And I think I have a lot of my friends and my cousins have a lot of kids, so I get to talk to them a lot. And once they reach a certain age, they feel like it's one or the other. They can either like science or they can like dance, or they can like music, but they can't like math. So normalizing that you can do both. You can like science and you can like music and you can like dance, and ballet is really important. And another thing is we always talk about, having role models and people to look up to, and we always put them on a pedestal and we see their success, and we very rarely talk about failure. I think normalizing failure as a part of learning is really important. I always say this, I failed grade 12 chemistry. I had to stay back in high school a year and retake a bunch of courses so I could go to university. And to really, like, it's fine. You fail math. That doesn't mean that you're not good at it. You have to, figure out the ways that you learn better. Just like I said, I convinced myself that I couldn't do programming before I had even tried it, just by hearing that, oh, programming is hard, and seeing that just a bunch of nerdy guys took programming courses. And like, you can be anything, you can look like anything, you can do, there's a broad range of what you can do. You can like makeup, and you can like programming, and you can like math. So I think normalizing all the spectrum of what you can be and what you can do is really important.
Thank you for bringing that up, Sarah, about the failure, because I think that's a huge thing. And even to this day in SciComm, when let's say something's retracted or something, or not even retracted, but if phosphine on Venus, you've got a phosphine signature, and then it comes out, well, maybe it's not phosphine. Everybody's like, oh, see, they're wrong. But that's what science is about too. And I think, and when it comes to education, I think there's this perception that, y'all are brilliant. You've never struggled ever, but it's important, I think, for kids to know that too. Yeah. Thank you for bringing that up.
Can I also say that we should probably make a shirt that says all kids are born curious, Sarah? I love that so much. And yes, we need to normalize failure, because failure is actually something that you're going to do a lot more of than succeeding. For example, when you start applying for grants and fellowships, you're not going to get them all. You just can't. And so that's just, I know it's not exactly the same, but failure in general, there's this stigma around it where, if you fail, then that makes you a bad student. Look, we're taught by people, and it matters how they teach us. A lot of times, professors or teachers might come into a subject and give it to you dry. I don't care how interesting a topic is, you can really make a topic dry just by how you present it. And you can also make it super exciting by how you present it too. And that changes, I think, a lot about how a student will absorb that material.
This came up in the Q&A where someone was talking about professors who have failed them, or you're getting university students who are failing classes because professors haven't done a good job, or they're ending up in mentally unhealthy places because of the experiences they've had in classes. And I do think that this is way more common than people expect it to be, and no one talks about it. They suggested that maybe it's because of the professors being employed by the university that they don't bring it up. How do you feel about mental health in astronomy and when you're in any space where you're doing sort of academic work or astronomical stuff?
I can speak to that, but I think I saw Sarah had her hand up. So go, please. Yeah.
So I am a professor, so I can talk from that sort of perspective. So I would say that since I was in grad school, I think the talking about mental health and normalizing conversations about it have changed a lot. And I think actually with the pandemic, it's something that is in the forefront. Every work environment that I am in, so this is true at the Canadian Space Agency, it's true at Western University, we are really worried about our students. We are really worried about our faculty. We are worried about the people that work at the space agency. And so mental health is absolutely something that is explicitly discussed, and people are really worried about it. I'm not saying that we do a fantastic job all the time. It's really hard. And it's especially hard now because you don't get to have those check-ins with people where you can see that they're not showing up and they look really sad. And, it's a lot harder when you're remote all the time. But I absolutely think that it's something, it's recognized that it's an issue. Being a graduate student can be really lonely and really tough. And it's also a time when a lot of graduate students are sort of in their mid-20s. And that's kind of an existential time where you're trying to decide who you are. And sometimes people have, they might lose their grandparents, or they can have a relationship explode, or somebody can get sick. All those things can happen at that time when you're also trying to decide who you are as a professional and as a person. And so that's just a really challenging time. And so a lot of issues come up at that time, which are just because of the age and what's going on in their lives, but also it's hard but I think it's definitely the case that this is something that is being discussed very explicitly by universities everywhere, and it's recognized as a problem, and we have not figured out how to do an awesome job at it, but it's definitely on the radar for everybody, I think.
Thank you for sharing that. That's really important to hear coming from a professor and from the sort of like the top level at universities. I think that really matters. I know, I mean, I don't, if anyone's saying they're having an easy time with the pandemic, I feel like they're lying, so.
Students especially, I mean, I can speak to the student perspective at least a little bit, and it's been pretty rough over here. So I appreciate that there's obviously concern among the professors for the students as well. It's encouraging to hear that, you know, you guys care, and it's definitely something that we're going to have to improve in academia in years to come.
I'm going to switch to a slightly lighter side of things, which is talking about science communication. This question actually came from Mariam Tsagaye, there we go, who is 17 years old from Fort McMurray and won the 6th annual Breakthrough Junior Challenge for her video explaining quantum tunneling. So for those of you who spend time on the internet, you may have stumbled across her recently. And her question is, why do you think, what do you all think is the best way to improve science communication? Which is a big question.
Okay, I can speak to that. I think one of the things that we all have trouble doing, even as experts, in fact, probably even maybe more so because we're so used to using jargon, is avoiding that jargon when we talk about science. And so it's difficult to find different ways to explain things to it like where you don't need to use any of the technical language. But I feel like that's also when you can do that, that's when you understand it the most. And if you can find analogies to something that we see every day, it's always so much easier for people to picture things in their mind when you give them, if I'm talking about, like, if I talk about my tablet. So, well, you can't see it, right? So if I'm showing it to you versus if I just tell you about it, you're not going to have the same picture. Whereas at least this way, I can explain sort of something that you're accustomed to, and that you look and see every day, or almost like that you see in nature. The moment that you can tie something like that into something you're trying to explain, I think helps a lot with science communication.
For me, my specialty is communication. I went to journalism school to learn how to communicate to people, right? So I have that advantage. However, that being said, taking complicated science ideas and translating them into something that's easy to understand by the general public, because of course at CBC, it's the general public. It's not like you're writing for someone, for the journal who might have, this background as knowledge. And I sometimes struggle with this, which is, don't assume everybody knows everything that you're talking about. You have to assume that they're coming from a place that is brand new. So simplifying it, but not talking down to people. There's a fine line there. And sometimes I'll be like, what do you mean people don't know what CMBR is? Which was, by the way, brought up in WandaVision. And I was so proud of myself when I was watching it. I was like, CMBR, I know what she's talking about. She's got, and it's just about trying to just, like I said, don't talk down to people, but also that enthusiasm. You don't want to be dry and talk about this. This is not what is really exciting, we are all passionate about what we do. We are all passionate about, you know, perseverance next week. That's going to be so awesome. You know, hope, you know, and Taiwan one, it's all this stuff that people are going to flipping Mars. This is so amazing. So, you know, instead of, you know, this spacecraft reached Mars, you know, it's going to have a helicopter. It's going to have a freaking helicopter. So this is the thing that we want to impart, which is our enthusiasm. And, you know, like I said, don't talk down to people, and find that fine line.
If I may add to that, as someone who is an amateur science communicator, not a professional like Nicole, I feel like a lot of us that do science communication through social media, especially, we do it in a one-way type of thing. So it's more of a, let me tell you about this thing, or let me explain this thing to you. Whereas trying to have a dialogue, or really trying to figure out what our audience wants to hear about, and having them drive the conversation. I mean, with space and astronomy, there's naturally a lot of enthusiasm and a lot of questions and a lot of curiosity. But I feel like when it comes to more important topics, well, not important, different topics like vaccination, for example, you know, if someone is an anti-vaxxer, you really have to understand why, and really understand their story and meet them where they are, and then communicate that to them. And something that I've learned is that I use a lot of storytelling. I include a lot of personal stories, and I feel like the times that I've had the most connection, or that I've been able to really have a meaningful connection with other people, is through telling those stories, through someone coming back and saying, you know, I also failed a course and I didn't think that was normal, or like, thanks for talking about this, or whatever. Just really being a human behind the science and behind all the things that are fun and interesting to us, just bringing that human side with us.
Absolutely. Having that two-way communication makes such a difference. And on that note, we actually had a question in the Q&A. Thank you for those of you who have timely questions in the Q&A. Which is talking about support systems and mentors. Can you all give examples of when you were mentored, when you mentored other people, whether or not you're currently open to assisting people? I know that Tracy Irvine in the chat asked if mentioned she was too afraid to approach Nicole, and I was so happy to see Nicole say, like, oh my goodness, yes, approach me. Yeah. Have any of you had mentorship experience, Sarah?
I'd like to share a mentorship experience that I set up for myself, because it's been amazing, and I want to share it with other people so you know about it. So I read this article, and this I think is also just another sort of lesson. Like, if you have a good idea and nobody's doing it, then you need to do it, or find people who can help you do it. And so, you know, as opposed to saying, oh, this thing should exist in the world and it doesn't, I mean, go make it happen. So this is an example that I did that's directly related to mentorship. Is I read an article, and it was in a newsletter for women in astronomy from the American Astronomical Society, and it was about something called a horizontal peer alliance. So it's basically where you set up a group of people who are peers, and then you are an alliance who can basically help each other solve problems and think through issues and strategize about your future. And the one that I set up was at Western University. So it was when I was a relatively early to mid-career faculty member. And so there's 4 of us in it. We are all about the same career stage. And for me, when I set it up, I wanted people who were research ambitious and had young kids, because those were sort of like the 2 things that I felt like I needed help with. And also part of the criteria that's recommended in the article I read is that they're people you're not competing with directly. So we have an engineer, a biologist, a chemist, and me. And we started meeting every 2 weeks for an hour, and we would basically set goals for ourselves and for the next meeting, and then every 2 weeks we would share, you know, how it went, and if something came up, we would tell people what the situation is and ask for help. And sometimes the goal was, especially when our kids were little, like it might be like get a haircut, or just the sort of thing that you were putting off and not dealing with, or maybe you had, like a sore knee and needed to actually go to the doctor and start, doing some physical therapy. Or sometimes it was, I want to put in a grant in 6 months and I need to start, thinking about it. The sorts of things that were important, but were falling off the table because they weren't urgent. You didn't have a deadline in a week. And it's been honestly one of the best things for my career. And I'm awesome friends with these 3 women. They're fantastic. And we've totally got each other's backs. And I am absolutely a better professional, probably a better parent, and also and I'm just happier with myself because I've got this team. And so I really recommend it. I think people often think of mentoring as being like a sort of a hierarchical relationship with somebody who's more senior and someone who's more junior, but also think about your peers. The other thing that's helpful is then you don't have that power dynamic. And those relationships with your peers are sincere, right? Because nobody is going to get anything. You're all at the same level. And then you advance, and then sometimes those people they're really freaking awesome, and they've been on your team for a decade, and so you have that relationship that's really sincere and really substantial. So that's something that I absolutely recommend for everybody. It's been one of the best things for me.
That's awesome. I've never heard of a setup like that. So that's a really useful tool to have in the toolkit. Thank you for sharing that. Has anyone else had any other mentorship experiences? I know that Sarah and Allendria and I have all at various times. It's been really nice in a completely non-professional and somewhat more friend-like, but still really useful to have way. We've gone observing in times that I never would have gone without anyone. Like if I were just on my own, and it's so nice to have people like Sarah and Allendria close by, excited about space, and willing to get up at 4 a.m. and go look at a comet, or stay up until 2 and look at Jupiter.
I'm in with that. Okay, wait, the 4 a.m. thing.
That was tough. Yeah.
Yeah, Neo-wise, I waited until it was visible at night in the evening. I was like, yeah.
It's the way to do it.
You know what? And that is really important too. One of the things, so I wanted to say, just as an aside, I'm involved in something at the University of Toronto next weekend, and it's about science reporting. And actually, this is the funny thing, Ivan Semeniuk was supposed to do it, but he was unavailable, but he recommended me, which is so amazing because full circle, like I said, he was the reason why, which is fun. But I was going to say the difficult part with being an astronomer is, as a woman, is I don't feel safe going out to the middle of nowhere. And, and so it's been, even here, like I live in the beaches and so it's right on Lake Ontario. I had this great idea when I came here. I was going to take my telescope out, I was going to put it in my car, just bring it down to the beach and have sidewalk astronomy or boardwalk astronomy. And I was like, I don't know, my gear's kind of expensive and I don't really want someone to take it. And I don't have anybody else with me. Then I found out there were some people in the area, but we haven't always kind of connected. I've been out with Blake Nanker, which was fantastic years ago, but it was always nice to have somebody. So that support is really important. So I think that's a good point. So put me on your list so if we can go out.
Not at 4 a.m. though.
I feel like in terms of support network, sometimes you find them in the places that you least expect them to. When I was doing my PhD, there was a point that I seriously just wanted to quit. And I feel like my support network came through Twitter and through science communicators, because they really made me realize why I went into the field in the first place and why I was excited about science. And it was from a community that I did not expect. And it was really their support that got me through that finish line. In terms of mentorships, I've had a couple of people that have been very supportive, very helpful. But I feel like an advice that I would give to the younger me would be to just ask people. you'd be surprised. Almost everyone is willing to have a chat with you, to, you know, to have a conversation, to help you out if they can. So just like, don't be afraid, don't be shy, don't be starstruck. They'll be very happy to ask. And one thing that I struggled with a lot as an immigrant who wanted to go to university and to navigate this like new system, I really didn't know. I just knew what I was interested in, but I didn't know how to get to the point that I wanted to. Like, my parents are high school graduates, so they couldn't really help me. So it was really just relying, you know, at first at the guidance counselor, then somebody in my class who knew I was interested in astronomy and told me to go to the York Observatory, and then running into Paul Delaney in the hallway and him accepting to take me as a co-op student. And I wish that I had, you know, had exposure to more people and was able to really ask more people about things to navigate ways around. So yeah, so my advice to the younger me would be to really ask, just ask anyone. And I feel like a lot of us sort of know what it feels like to navigate those paths too. And my policy is, if I've made it somewhere, I'm going to keep the door. After Michelle Obama, I didn't come up with this quote myself, but if I make it somewhere, I'm not going to shut the door behind me and be like, okay, bye. Like, I want to keep the door open for other people to come in and help them sort of come in. And I feel like a lot of people have the same philosophy. So just ask people.
And I should add, I want to say RASC, the Toronto Centre from 10 years ago, I think it's about that. I've made some wonderful friends who will last a lifetime and who supported me and encouraged me. And, you know, you just never know with that. That was by a fluke, by walking up to, you know, the observatory. So you never know.
I'll also add something. I guess like I think a lot of us touched on having like a sort of, I guess, a network of people that like sort of as mentors, like as friends. And you know, when we think of that, I think a lot of times we think of people who are, let's say I'm a grad student, so another grad student as well, rather than, I don't know, like a professor. But in my case, I had the professor that I worked for, who was my research advisor in undergrad, was a mentor to me. I'm literally here where I am. I love the stuff that I do because of him. It's Sean Tulin at York University. And times when I would lose faith in myself, he had faith in me, and that was enough for me to be like, okay, well, if he has faith in me, then I must be okay, you know? So you can find mentorship in professors as well. And I feel like that having a mentor and a professor is like, it's a different kind of mentorship, and it gives you, I guess, more like, I feel like it's more as a push to and to like I guess make sure that you really kind of know that you really do belong there, whereas like the friends are more of a support network. They're also, it's kind of interchangeable also, but it's just having, because they're different in our lives, it gives you a different sort of a different vibe, and you can get different benefits from it. And I find like the professor having a mentor as a professor was, or a professor as a mentor was really, really important for my undergraduate career.
There was a comment in the chat as we were talking about this, that you have to choose your professors carefully, because you can have some really amazing experiences, but you can also have some negative experiences too. And I guess I would say, don't let the negative experiences discourage you, because look, we have an entire virtual room full of people who are awesome and so supportive and excellent mentors, and you just got to find the right ones, you know? So we're reaching 9 o'clock Eastern time, which means that I am a terrible astronomer and should be going to bed, but I wanted to leave with Sarah actually kicked this off for us already with advice for the next generation of astronomers. Do any of you have any go-to advice, like a quick one-liner that whenever you have someone small and come up to you and say, I want to get into space, what's your answer?
To me, one thing that really helped me was joining an astronomy club. it's literally the reason, it's the reason why I got into astronomy in the first place, because I enrolled in college as an undecided major. I didn't, I wasn't the kid that knew that I was going to do astronomy from childhood. And so if you have an astronomy club that you can attend, go. If you can do star parties, go as well. It's just amazing to share love for space with a group of people that feel the same way. And I think that it's so enriching for you. I found it like, it was beautiful. It was a beautiful experience for me. So definitely join astronomy clubs.
Nicole, did you want to throw something in as well? I can plug the RASC here if you'd like.
Yeah. Well, no, it's honestly, if someone says that, especially when it's someone young, I'm like, great, good, because space is amazing. And I think of myself when I was 8 years old and seeing the world outside my world, just to see that it's so much bigger and so much more wonderful than you can ever imagine. And speaking with astronomers all the time, and that one of the underlying themes is, as soon as we think we have something figured out, something new ends up coming up. And so that's the beauty of astronomy and just the love of it.
Thank you. Sarah Gallagher or Sarah Mazuri, have you got any last thoughts?
Sure. So I would say, I think one of the things that that's really important is that you talk to kids about being observers, and it's always surprising to me when I teach first year astronomy in undergrad, how many students don't know that the moon is up during the day sometimes. And so there's just things about the world that people don't necessarily pay attention to. And I think that's also one of the hallmarks of being a scientist, is to be an observer and to pay attention and, go outside and wait until you're dark adapted and look up at the stars and notice the moon, and all of those things are what makes a great scientist, is somebody who pays attention and notices and observes. And those are really important qualities. And they're also lovely. I mean, we are all here because we love being outside and go and be, it's so peaceful. And, to go outside and look up and be able to, let your mind think about the stars and what's in between the stars, and really just enjoy that space of being outside. But being an observer is really, really important. And so, and you can do that in all aspects of your life. And it's really valuable.
Thank you. Sarah Mazuri, any last thoughts?
A few. One would be, don't let anyone tell you what you can or can't do. It's up to you. You don't need to go to university to be an astronomer. You can study whatever you want. You can do astronomy as a hobby. If anybody asks you, what can you do with an astronomy degree? I wish somebody had told me that a lot earlier. But professional astronomy jobs, or as a scientist at a university or at a space agency, they're very few and far in between and very challenging to get to. That's the reality of it. But the skills that you gain through studying astronomy open you up to many other job opportunities. So it's good to be aware of what other things you can do with a degree in astronomy, if that's what you choose to do, and be ready to have that as plan B and still be happy with it before you commit to it.
Thank you so much. Thanks everybody for all of your thoughts on the topic. I had a really wonderful time tonight. We've had lots of very happy attendees in the chat. So thank you all for those of you who have come and stayed for the evening. I wanted to make one last quick plug for RASC, because what kind of employee would I be if I didn't? So RASC, if those of you who are in the chat and do not know what we are Canada's premier amateur astronomy club. We have centers all across Canada. A lot of stuff is on hold because of COVID, but many of our national offerings are now online, obviously. And so please do come join us. Starting In about a month or two, we're launching a new system that also allows for members to more easily communicate with each other. And in so doing, we're hoping that that really builds those ties across the country, and that everyone gets to find their mentors in the society. I believe Allendria has one final plug for SkyNews, and I'll let her do that before we bid you all a lovely evening. Allendria, over to you.
Wonderful. Thank you, Jenna. And yeah, I wanted to thank everybody here for joining us tonight, both the panelists as well as the audience. It was so funny to kind of hear Nicole talk, like just all of you talking about mentorship. And I just remember one of my first interactions with Nicole was about astro photos, like anything I'd taken that was space related. And I was like, oh, not me. God, they're terrible. Ugh. And then I sent along one of my aurora shots, and it was published in a journal. So it was, it's, there you go.
It was definitely not terrible.
Thank you. And so, yeah, Sky News. I just wanted to remind everybody that the March-April edition of Sky News has just hit the newsstands. We have a lot of great stories in it. Blake Nincaro, who's been in the chat, he's got a story about the modern makers of telescopes. And as well, we have a couple of really awesome features about Canada entering a new golden age of humans in space. And so it's really exciting. And yeah, I think that's about it from me, and wonderful seeing everybody here, and clear skies.
Thank you so much for sharing your time with us, both all of you as panelists and all of you as guests. And we'll see you the next time that we host an event.
Thank you for having me.
Thanks for coming.
Thanks so much.
Having us.
Thank you.
Have a great evening.
Thanks, everyone.